Okay, so where we left off was part B of number 5. We were finding the coefficient of friction. We had just found, make that bigger, we had just found the normal of the house. And of course the normal in the house, whoops, let me move my hand out of there, is the friction of the ground. And earlier we had found the normal of the ground. It was 980 newtons. And so from this we can get our coefficient of friction, and it should be something like 2733. The point in front, of course. Okay, so that's B. Now C you might have found a little confusing, but it shouldn't be that bad. It says find the magnitude and direction of the contact force at the base of the ladder. So what it's talking about is, if we go back to the picture, we found, my hand is causing a reflection. We found an X component that the ground is putting on the ladder, and we found a Y component that the ground is putting on the ladder. So really, the ground is putting a force at an angle on the ladder. We just always break it up into its two components because we know the X is the friction of the ground, and we know the Y is the normal of the ground. So this is your 980 newtons, and this one is your 67.79 newtons. And what they're asking you for is just the force of the ground. So square them, add them together, take the square root, and use tan to find the angle. And that should give you, when you do that, the normal or the ground force should be 1015.93 newtons, and the angle is going to be 74.72 degrees. And again, that will be clockwise. Here it is. Clockwise up from the ground, or counterclockwise up from the ground. Don't expect that the angle is going to be the same thing that the ladder's angled at, right? Because that would mean then these two components would be proportional to that angle, and they aren't. They're dependent on the other forces, and they're going to change depending on who climbs the ladder and how high up they climb. Okay, so that's all it was for part C. All right, we have one more in that sheet, number 6. And number 6 was the fun one. The fun one because it's finding the mass like we were doing the last day. So you have a ladder, and it's 10 meters long, the full length, and it says a person is it's uniform. So this is FG of the ladder, and it says the person is 3/4 of the way up. So this then would be 7.5 meters. When it begins to slip, it's leaning against the side of the building. The mass of the ladder is 20 kilograms. The angle is 60 degrees. Coefficient of static friction and the ground is 0.4, and it wants to know what's the mass of the person. So draw in your other forces. This will be the normal of the ground. This will be the friction on the ground. This will be the normal of the house, and there's still no friction up here. We'll leave that for the next question. Okay, so you could start with sum of the forces in the y direction. And it's going to be 0. So there's the F normal of the ground minus the weight of the ladder minus the weight of the person, equal to 0. So F normal of the ground will equal m of the ladder g plus m of the person g. But we can't find it because we don't know the m of the person. So then, I'm just trying to find the edge of my page. Oh, I'm far off. Okay, so then sum of the forces in the x direction also has to equal 0. And so it'll be F friction of the ground minus F normal of the house equals 0. So F friction of the ground equals the normal of the house. And we know friction equals mu Fn of the ground. So the F normal of the house is going to equal mu brackets this stuff. So m of the ladder g plus m of the person g. And this we will sub in to our sum of the torque. Okay? So sum of the torques equals 0. So there should be a torque from the normal of the ground, a torque from a friction on the ground, torque from the normal of the house, torque from the ladder, a torque from the person. Again, if we pick our pivot point here, then these two are going to go to 0. Normal of the house is going to make it rotate counterclockwise, which is positive. The two weights clockwise, which is negative. So 0, and remember these are 0 because they go through the pivot point, which means their r's are 0, right? Because torque is rf sine theta. And r is the distance from the pivot point to the f, and if that's 0, the whole thing is 0. So this is r normal of the house, f normal of the house, sine theta normal of the house, minus r of the ladder, fg of the ladder, sine theta of the ladder, minus r of the person, fg of the person, sine theta of the person equal to 0. So where this f normal of the house is, we're going to fill in our f normal from down there. So we're going to bring, whoops, where did it go? We're going to bring it up. So it becomes r normal of the house, bracket, mu m of the ladder g plus m of the person g, and there's a bracket before those mu's, and then sine theta normal of the house, minus r of the ladder, m of the ladder, g, sine theta of the ladder, minus r of the person, m of the person, g, sine theta of the person equals 0. So every term here is going to have a g in it, so we can cancel them. You can wait if you want to multiply through first, but they're definitely going to go. And then remember, when you multiply through, the r, the mu, and the sine theta have to go with the m's. So it's going to be r normal of the house, mu, m of the ladder, I canceled my g, sine theta normal of the house. And then the next term is going to be r normal of the house, mu, m of the person, canceled my g, sine theta normal of the house. The next term, r of the ladder, m of the ladder, sine theta of the ladder, and the last term, r of the person, m of the person, sine theta of the person equal to 0. We're solving for the person, so keep this term and this term. So r normal of the house, mu, m of the person, sine theta normal of the house, minus r of the person, m of the person, sine theta of the person. Keep those on this side. Take the r of the ladder, m of the ladder, sine theta of the ladder over, it becomes positive. Take r normal of the house, mu, m of the ladder, sine theta normal of the house over, it becomes negative. Pull out your m of the person, r normal of the house, mu, sine theta normal of the house. Whoops, don't close that, that's just an optical illusion. Minus r of the person, sine theta of the person, and then you're going to divide by the bracket. So m of the person is going to equal r of the ladder, m of the ladder, sine theta of the ladder, minus r normal of the house, mu, m of the ladder, sine theta normal of the house. And it gets divided by r normal of the house, mu, sine theta normal of the house, minus r of the person, sine theta of the person. So remember, I had said yesterday's videos, you got to be careful of your subscripts. So now let's fill things in. R of the ladder, it was 10 meter long, so in its uniform, so 5 meters. Mass of the ladder was 20 kilograms. Angle, it said the angle at the base was 60 degrees, so the angle up here would be 30. So sine of 30. Normal, r normal of the house, the full length, 10 meters. Coefficient was 0.4. Mass of the ladder, 20 kilograms. And the angle for the normal of the house will be this one, so that's 60 degrees. Sine of 60. On the bottom, r normal of the house, 10 meters, mu, 0.4, angle 60. R of the person, it said that they made it up, I have no idea how far, and I'm trying to find out, oh yeah, 7.5 meters, gonna run out of time, and sine of 30. Punch your